Explorer 1, NASA's farthest traveling rocket, proceeds with its astonishing endeavor through space, perfectly conveying huge data from the deepest regions of the universe. For nearly 50 years, this amazing space test has changed our understanding of space. However, the spacecraft has been transmitting upsetting data back to Earth, leaving the entire space industry in shock. Are these disturbing signs the result of a technical breakdown or the actions of extraterrestrials? Join us as we uncover the truth behind these shocking transmissions. Since the dawn of mankind, analysts have been excited by the secrets that lie beyond our eminent limits. This curiosity incited the noteworthy launch of the Traveler 1 and Wayfarer 2 transports, among other magnificent space missions. These earth-shattering missions, which had been discussed for a long while, began with the launch of Wayfarer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that same year, Voyager 1 followed suit. These twin tests, each weighing a huge 720 kilograms, comparable to a small vehicle, were propelled into space during a unique alignment of the outer planets. Throughout their amazing odyssey, these brave journeys navigated various directions and speeds, leading to a critical moment on December 15, 1977, when Traveler 1 outperformed its identical twin due to variations in their paths. Since then, Wayfarer 1 has become a critical resource, providing us with an abundance of data and unraveling space-related mysteries. Before we delve into Traveler 1's surprising new discovery that stunned the entire space industry, let's explore the outstanding images captured by the rocket during its crucial Jovian imaging mission in 1978. Pilgrim 1 was situated around 265 million kilometers from Earth. From this vantage point, it transmitted a staggering number of photographs back to Earth. In January 1979, it embarked on an extraordinary 100-hour endeavor, capturing a mesmerizing time-lapse film showing 10 rotations of Jupiter. A cornucopia of 3,750 images allowed us to observe Jupiter's heavenly dance in vivid detail. In the ensuing months, Pilgrim 1 wandered through the Jovian moon system, making a striking discovery: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's captivating area. To ensure safe passage and prevent a potential collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Pilgrim 1 continued its divine venture around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. With the culmination of the Saturn mission, scientists decided to conclude the Adventurer planetary mission but continued pushing both Adventurer 1 and Pilgrim 2 beyond the limits of our planetary system. They traveled through space at a remarkable speed of 325 million kilometers per year. In January 1990, a new chapter began, the Pilgrim interstellar mission. During this phase, Pilgrim 1 captured some of the most renowned photographs in history, immortalizing the Sun and the majority of the planets. One individual who played an essential role in extending the missions beyond their initial goals was the prominent astronomer Dr. Carl Sagan. As a part of the Voyager mission's imaging team, Sagan vigorously advocated for capturing one last set of images as a farewell gift to humanity. His enduring determination bore fruit on February 14, 1990, when Adventurer 1, positioned 6 billion kilometers from the Sun, embarked on a visual journey well known as the Family Portrait. These staggering images, totaling 60, added to the spacecraft's remarkable collection of 670 photographs during its encounter with Neptune. Explorer 2 achieved a remarkable feat by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever recorded within our local planetary system. As the rocket wandered within 280 miles of Neptune's blue methane atmosphere, it provided us with remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest residences within our planetary system, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as its nitrogen gas-spewing ice volcanoes that propelled frozen particles 5 miles into its amorphous atmosphere, also captivated our imagination. These exceptional discoveries broadened our understanding of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary group. But don't go anywhere, the Voyager 1 rocket has recently made one of its most startling discoveries. However, first, we should explore what it has accomplished in the last 45 years. The achievements of the Wayfarer twin tests have been nothing short of phenomenal. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these distant worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be interacting with geological activity. Pilgrim 2, in particular, accomplished several outstanding feats during its journey. It made history in 1986 by becoming the first spacecraft to fly by Uranus. Only 3 years later, it achieved another remarkable accomplishment with a flyby of Neptune. To this day, it remains the sole spacecraft to have ventured on such a path. As the Pilgrim rockets continued their journey, NASA implemented various measures to extend their operational lifespan. In recent years, non-essential parts and heaters have been deactivated to conserve energy, ensuring that these gallant explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable undertaking from the very beginning, the end of the Pilgrim missions is both a moment of pride and a touch of melancholy. Their heartfelt dedication and passionate efforts have far surpassed their initial expectations. The wealth of data returned by the Voyagers has provided valuable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Pilgrim 1 and Pilgrim 2 were no ordinary space tests. They were meticulously designed as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the rockets captured images and data while traveling through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to astound scientists and the public alike. The rockets began transmitting images of Jupiter before reaching the gas giant. These early pictures, showcasing the swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the distinct images they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most prominent volcanoes had erupted with a force 100 times greater than Mount St. Helens, covering an area almost the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it is essential to note that the photos they captured did not include Mercury and Mars for various reasons. Besides the Traveler 1 and Traveler 2 interstellar tests, NASA has also operated other prominent spacecraft like Explorer 10, Explorer 11, and New Horizons. Adventure 1 passed by Explorer 10 on February 17, 1998, marking the occasion when Explorer 10 became the farthest spacecraft. Traveler 1 continued its solo journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space tests in sight to witness it, NASA did not publicly announce this extraordinary achievement until 2013. What techniques ensured the success of the Pilgrim missions? One method stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played a crucial role in propelling Wayfarer 1 and Voyager 2 on their daring mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two intrepid rockets, Explorer 1 and Explorer 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they engaged in a celestial dance with some of our solar system's heavyweight planets. These planets formed groups that performed an incredible dance, using their immense gravitational pull to slingshot themselves on their way. This technique allowed them to conserve precious fuel and gain the necessary speed to visit multiple destinations. Delving into the fundamentals of gravity assist, also known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Pilgrim 1 approaching Jupiter, a massive gas giant with a corresponding gravitational pull. With careful precision, Pilgrim 1 swung around Jupiter at the perfect angle and speed. Jupiter's gravity pulled at the spacecraft, accelerating it to a higher speed and giving it a significant boost. Performing a gravity assist maneuver requires exceptional precision. If Pilgrim 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its intended course. The level of accuracy required is daunting. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on an extraordinary journey through the solar system. Traveler 2, for instance, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of critical importance in making the mission feasible, as they enabled the spacecraft to reach these distant planets in a relatively short period of time. Gravity assists not only saved fuel, but also allowed the Voyager spacecraft to reach multiple destinations within a limited time frame. These maneuvers were akin to slingshots in the cosmic ballet, where each gravitational assist propelled the spacecraft to a new destination with great speed and efficiency. In essence, gravity assists were a key factor in the extraordinary success of the Traveler missions, allowing them to explore the outer planets, collect invaluable data, and expand our understanding of the universe. So, what about Traveler 1's most recent discovery, which has sent shockwaves through the space industry? After spending nearly 45 years in space and continuously transmitting data from its unique position, Traveler 1 has encountered a mysterious signal that has left scientists both puzzled and intrigued. The signal is unlike anything the spacecraft has encountered before, and its origin remains a profound mystery. As scientists continue to analyze the data and decipher the message embedded within the signal, the entire space industry is on edge, eagerly awaiting further revelations. Could this signal be a message from an advanced civilization, reaching out to us from the farthest corners of the universe? Or is it an anomaly, a glitch in the spacecraft systems after decades of service in the harsh environment of space? The truth remains elusive, but one thing is certain. The Traveler missions continue to captivate our imagination and push the boundaries of human knowledge. As we stand on the brink of new discoveries, we must remember that the legacy of Traveler 1 and Traveler 2 goes far beyond their incredible accomplishments in exploring the outer planets. These spacecraft have inspired generations of scientists, engineers, and dreamers, and they continue to remind us of the vastness of the cosmos and the endless possibilities that await us among the stars. With the impending conclusion of the Traveler missions, we bid farewell to these intrepid explorers, but we do so with a sense of awe and wonder. Their legacy will live on in the annals of space exploration, serving as a testament to human ingenuity, perseverance, and our unquenchable thirst for discovery. As we look to the future and contemplate new missions to the farthest reaches of space, we carry with us the knowledge and inspiration gleaned from these remarkable journeys. The spirit of exploration that fueled the Traveler missions will continue to drive us forward, pushing the boundaries of our understanding and propelling us ever closer to the stars. And so, as we await the next chapter in the saga of space exploration, we stand united in our curiosity and wonder, ready to embrace the mysteries that lie beyond the horizon. For in the words of the great Carl Sagan, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. As we continue to gaze into the depths of space, we do so with the knowledge that we are part of something much larger than ourselves. A cosmic journey that began long ago and will continue to unfold for generations to come.